there, young future engineers. In this video, we will be talking about the application of calculus in the field of chemical engineering. Did you know that calculus have been very useful in sciences, businesses, company partnership, and of course, in engineering for 100 of years? Undeniably, calculus plays a very big part and has a great impact in the field of chemical engineering. In the concept of science, exact measurements are indeed very important for accurate results. Even the time rate or how fast a liquid is being poured should be considered. Formations of atoms, elements, and compounds explains how the phase of something from solid walls, sticky liquid paints, and even in medicines. But in the real sense, how can calculus really be applied in chemical engineering? Let's take a look at this. One of the most notable catastrophic events in the history is the Chernobyl nuclear disaster. Chernobyl is a nuclear power plant in Ukraine. On the day of the disaster, thousands of people and living organisms were exposed to high levels of radiation. Radioactive dust was sent far and wide, transported by winds to different parts of Ukraine, Sweden, and to neighboring countries. For days, thousands of clay, sand, boron, and dolomite were dropped by helicopter into the burning reactor. There are numerous theories as to what happened on that day. As the workers at Chernobyl Reactor 4 were performing a test to see if the turbines could provide enough energy to keep the coolant pump running, if there was a loss of power, and if they could keep them running until the emergency diesel generator kicked. They'd done the test before, but the test had been unsuccessful. They turned down the reactor of 25% of its capacity. But a problem arose when the power plummeted to 1%. They tried to increase the power, but what ensued was a massive power surge. The reactor emergency shutdown failed. One engineer had wanted to abort the test, but was told by a senior to carry on. The reactor then became even more unstable, and this caused considerable pressure. Want to know more future engineers? Now, let's go to radioactivity. So, what is radioactivity? Radioactivity refers to the particles which are emitted from nuclei as a result of nuclear instability. Let's dig deeper. Radioactive decay rates are normally stated in terms of their half-lives. Radioactive half-life for a given radioisotope is the time for half the radioactive nuclei in any sample to undergo radioactive. Radioactive elements decay can be solved according to this exponential model. Radioactive isotope equals original amount and multiplied to the expression h to the power of kt, where t is the time and k is the rate of decay. In order to easily compare the rate of decay of several isotopes, if we can divide the original amount from both sides, it means that the half-life of an isotope is independent of how much of it will take the same amount of time for half of that sample to decay if we take natural log both sides. Of these equations, we see natural log of 1/2 equals the product of k and t. It takes to decay by 1/2. We see that the half-life equals natural log 1/2 over the rate of decay. And if we go back to the equation and solve for k, we can find out that the k, if we know the half-life natural log of 1/2 divided by that half-life equals k, which can be used into exponential model. For further understanding, let's take this example. So we're looking for amount after 150 years. So k equals natural logarithm times 1/2 over 68.9 years, so it will lead to negative 0.01. Then multiply it to 250, then the answer will lead to negative 2.51. Then put the answer to the power of e, and the answer is 0.081. And then multiply by 100, so approximately 8.086 grams. Calculus is a branch of mathematics concerned with the calculation of instantaneous rate of change. Chemical engineering is an engineering that uses principles of chemistry, physics, and mathematics. Chernobyl nuclear incident is an incident wherein radioactivity was involved. As a matter of fact, Chernobyl nuclear incident was famous for being radiation active throughout the years after of its explosion. The half-life of radioactive elements can be solved or calculated by using exponential equation.